Hey, we're going to spend 2 days on complex numbers. We're on page 50 of your student journal. And just so that you're clear, you guys, complex numbers, if you think of all the numbers you've ever known so far, we call those real numbers. So when we're looking at our page 50 of our student journal, this side, these are the numbers you're familiar with, unless you already know about complex numbers. Okay? And that's actually, these numbers, these real numbers, are a subgroup of complex numbers. Okay? It's just, we have this other group of complex numbers that we call imaginary numbers. And imaginary numbers, they're all around us all the time. You just look around. You can't see them right now, but eventually you'll be able to see them. You'll be able to use your imagination more. Okay, this right here, whenever you have the square root of a negative, that's an imaginary number. So we've lied to you all these years saying you can't have roots of negatives. Well, you can't. I guess technically we didn't lie because in real numbers you can't. But when we're dealing with imaginary numbers, you can. Okay? And we call the square root of a negative, square root negative 1, we call I. So rather than writing it as square root negative 1, we go, whoa, we're not going to put a negative in there. We're just going to call that I. Okay? That's why around here you start seeing this. I see. Get it. I heart math. Get it? I.
It's up there too. That's what that is. I was like.
I get it. I get it. All right. So it's pretty radical, even though we're being negative about it. What I want you to do right now with the groupie, complete exploration 1. Best of your ability. Give you a couple minutes there. So multiple answers. You're going to have put as many of these different subcategories as possible for root 9 and so on. Okay, now that you've been talking about it just for a few minutes, let's review a couple things here. First, real numbers are all fractions, decimals, every number we've ever learned. Rational numbers are numbers that can be expressed as a fraction. The word ratio means fraction. It's a comparison. So if you can write it as a fraction, it's rational. So irrational are those ones like pi, root 2, root 7, root what? 5. How about root 9? Good. Root 9 is actually 3. Okay? So root 9 is an integer. Root 9 is also a whole number. Whole numbers are all counting numbers and 0. Which means a natural number is those are our counting numbers. So like 1, 2, 3, 4, 5, 6, 7, 8, 9, all those. Those are natural numbers. When we put 0 in there, we now have whole numbers. So this includes 0. So it's our counting numbers plus 0. Okay? So, guys, these are just examples over here, right? That's not the only thing that's an integer. Integers are all of our negatives. Yeah. 0 is an integer. Yep. So 0 would be integers would be all of our whole numbers plus their opposites. And then rational numbers brings the things in between the whole numbers, like 1/2, 1/4, 1/3, all that stuff. So the rational brings in the fractional piece. And then the irrational is all the stuff that never terminates and never ends. And then our imaginaries deal with our roots of our negatives. Okay? So what is the most specific name for 9? So the most specific is as far down as you can go. It's a natural number, which means it includes, root 9, which is actually 3. It includes this, and that. It's all of those, but the most specific name is natural.
So does that mean all whole numbers are integers and not all integers are whole numbers? jet and plane, you know, like how they say all jets are planes, but not all planes.
Yeah, the farther you go down, if there is a box underneath another box, then this is that. And it's also that. And it's also that. Yeah. So 0, what's the most specific name? It's a whole number. That's the most specific name. A 0 is a whole number. It also is an integer, a rational number, a real number, and a complex number. Yeah. How is it rational? So 0 over 5. 0 over 5 is 0. It can be expressed as a fraction. Okay? So if you can express it as a fraction, it's rational. It's just, you don't do 0 over 0. That's bad. We're not going to go into that right now. Okay? This is -2. So what's the most specific name? It's an integer. What's that? Yeah, I know. Crazy, right? All right, what's this reduced to? 2/3. That is? It is rational. Is it an integer? No, it's not a whole number or its opposite. So the most specific is rational. So it's rational, real, and complex. √2, can that be made into a fraction? No. Therefore, it's irrational. That's the most specific name, is irrational. Okay? However, we could call it irrational, we could call it real, and we could call it complex. So anything there. And √-1 is? Imaginary. Okay? But we could also call it complex.
Is there another subgroup besides complex?
We're ending right there. Okay. All right. We're not doing any more.
Yay!
Okay. Let's move on. I want you guys to take a look at Exploration 2. Now, I got to say, I don't like these answers right now on Exploration 2 because I personally believe that you should have I personally believe you should have plus minus in front of all of these. So we're going to put plus and minus. Just so you know. All right, we're going to put those pluses and minuses. All right, so now, based upon that, I want you to match each equation with its solution. You can work together. Okay, take some time. All right, let's check your work. There we got it. Now, you'll notice on my answer key, when I'm solving this and I get down to x equals plus minus √-1, we call that I. Plus minus I. Now, when I get down to x equals plus minus √-4, notice you can break this apart. You can say, well, -4 is in there. We can call that √-1 times √4. Well, √-1 we say is I, and √4 is 2. So we call that 2I. Okay. How many figured that out? Okay? And same thing on this one, except for, I don't know why I have a radical sign. That's totally not radical. So that radical symbol should be, let's just get rid of that. We'll pretend like that didn't happen. Call that plus minus 3I. Okay? Now, I didn't put the plus minus on all my answers down there, but we should have. Okay, how many think you got it? Not too much difference there when you're dealing with these imaginary numbers. Okay, any questions? Yeah, your homework? Good thinking, man. Let's go ahead and take a look at your student journal then. Okay, I want you to open it up to page 53. There are a bunch of different things in here. Okay, need everyone's attention back here. I will tell you there are a bunch of different things that we're going to have you do to imaginary numbers. Just like with rational numbers or real numbers, we taught you what they were. And then we said, hey, we can add them, and we can subtract them, we can multiply them, we can divide them, and then we can factor them, we can do all this cool stuff to them. Well, you're going to do a lot of that cool stuff to this. You're going to simplify them. So first, simplifying 1 through 6. I think you know how to do that, but I want you to try number 1 and number 4 right now. Okay, if you're waiting around for the class, you can do the others. We're going to have to do them all at some point, but do one. Okay, so my guess is most of you had no problem with 1. You go, hey, that's just root 49 and root -1, which gives me 7i. That's my answer. No plus minus because the radical's already there. We call that the principal square root. Not because Mr. Snow likes it. Okay, 7i. Okay, and here we can keep the -2 and we could break root 100 up into root -1 and root 100. -2 and root -1, and that's I, and root 100 is 10. So -2 times 10 is -20i. How many got it right? Neato burrito. Questions? Yes, sir?
How come it was not plus or minus?
It's not plus minus because the radical's already there. You didn't impose it. So if you start with the radical, you don't put the plus minus. It's only if as you're solving you impose a radical. You put the radical. So if you start the problem without a radical. Okay? All right. Any questions? Yes, Aaron? Number 3, you have to think about simplifying radicals, right? So, -1. What 2 things multiply to make 45, and one of them's perfect? Root 9 and root 5. And then we simplify each part. Root -1 is I. Root 9 is 3. And root 5 stays root 5. 3i root 5. I think that's cool. Because that's not how we write it mathematically. Yes, ma'am? Anytime we root -1, so that's this negative sign out in front. Yep. So anytime you see a negative, it's like having a -1 times that. Kinsey? Correctamundo. Yep. Well, -1 becomes I, right? Okay. Yep. No, 25. 5 times 5. I'll come over and help you. Try number 7, please. Okay, you guys, when you're dealing with complex answers, you are actually, or complex expressions, you're actually dealing with a real portion and imaginary portion. Okay? And this is up in your notes on previous pages, but I thought I'd address it as we encounter it. We call the form A plus BI. Okay? A plus BI. This is your real part. This is your imaginary part. Now, how do you know that's the imaginary part? Because the I. And the real part doesn't have an I. Okay, really, it's that simple. Okay, so when I'm looking at this, the real part of this side of the expression or equation is -10x. And the real part of this side is 30. So if I'm solving for x, I'm just saying -10x equals 30. So what's x? -3. That's all you do. And then when I'm solving the imaginary part, when I'm looking at the imaginary part, I'm saying, well, I equals -I, or -yi.
It seems unnecessary to put those 2 things into one equation.
Well, that's because we haven't graphed it yet, so we'll graph them eventually. Okay? I equals -yi. Hi there. Oh, thank you. I appreciate that. They really enjoy working with me. So. Thank you. Hey, so if I'm dealing with this, I want to get y by itself. How do I get rid of y, or the I? Divide by -i. And if I divide by -i, I end up with y equals, what's I divided by I? Come on, what's I divided by I? 1. And positive divided by negative? It's the same math, right? So you're just doing two different parts. You can do it. Yes? Y is equal to negative 1. Yes. Negative 1. This is a negative 1. Okay. Ladies and gentlemen, your assignment today, I want you to take a look at the next page. You're going to finish page 53 that we started. And then I want you to look at this page, and I want you to go through 1 through 14, as well as 16, 17, and 18. Don't cross out 15. Okay, we will talk about that. But you're doing everything on that page with the exception of 15 and 19. Now, you may look at this and go, I don't even know what I'm doing on those. You're right. You might not know. But you might know. Like here, think about what you're doing. I mean, you have a real and an imaginary. You're adding to a real and imaginary. What can go together? The reals can go together and the imaginaries can go together. Okay? Do your best on it. I realize that some of it's new and confusing, but some of it you're going to understand. It'll give us a great place to start tomorrow. Any questions? Very good.